So, Dr. Cathomen, thank you for taking a few minutes to meet with us. We know you're very busy, but we're nearing the end of our annual research grant cycle and just had a few questions on your very important and groundbreaking project titled Prime Editing Base Correction of UNC13D. So as your proposal shared, approximately 70 interventional genome editing approaches, including strategies based on CRISPR, base editors, and prime editors, are currently being evaluated in clinical trials. But your project proposes the use of twin PE to rewrite UNC13D exon 14 as a strategy capable of correcting many known mutations in exon 14, which is known to contain many FHL, familial HL3 causing mutations. So the first question that we had, because this is a very important and exciting project, is what will the impact be on the community and research when this project is finished?
We live in exciting times in terms of genome editing and the potential that we see that it has also now in clinical trials. And I think that the first CRISPR medicine was approved last year in the US, this year in Europe. And I think based on what we see is going on, and as I mentioned, the clinical success of some of these approaches, I thought that we can use similar technologies now also for FHL3. Because gene correction, which is also based on CRISPR, doesn't really work in hematopoietic stem cells, we thought we need a different approach. And you can use base editing or prime editing. With base editing, you can correct one single point mutation at a time. With prime editing, we propose that we can correct all mutation in one exon. And I think this would be a novel approach, which has not been described so far. And I think if this works in this model setup, let's put it that way, I think we can extend this, of course, to other mutations in other exons of this disease, but I think also, of course, extend it to other diseases. I think if you now talk about the Histiocytosis Association, I think there are many different, let's say, diseases which are caused by point mutations in different genes. And I think you can extend this, of course, to other genes as well.
That is very exciting. And I know that HLH is still one of the most devastating of the histiocytic disorders. And so to hear something that groundbreaking gets us really excited for the future. I'm very grateful that you're interested in working on this. And so as you know, the annual research program grant amount is $50,000 US. And so just really briefly, we were hoping to understand from a big picture, how will the funding help you in getting this project over the finish line?
Yes, I think we have started to work on FHL3 in particular a couple of years ago. We have done some, I think, nice work in the mouse model for FHL3, also with genome editing and base editing. And I think we haven't done any work with prime editing. And prime editing is something new to us. And I think that's also why we secured, let's say, a collaboration with a person in Germany who has a lot of experience with prime editing. And I think this will really help us to actually start this project. But I think I wrote this in our application. What is special about prime editing is that you need these very long RNAs, and they have to be chemically synthesized, and they're expensive. I think we put down $20,000 just for the RNA that we have to have synthesized by companies, because we cannot do it on our own. And I think this would really help us to get this started, to do it in primary cells first, in T cells, and then in patient cells later on. And I think this is what really would help us to get this project off the ground and hopefully to a successful conclusion.
That's wonderful to know, because the reason why we asked you to meet with us today is actually that your project was incredibly, the scientific committee from the Society and the Histiocytosis Association board were incredibly inspired by your project, and you've actually been selected for funding, and so that's why we wanted to connect with you.
Oh, wow, that's very exciting. Thank you very much. Right before Christmas, I think that makes it even more exciting. I'm very thankful, I think, to hear that news. And I think my, let's say, colleagues in the lab as well. I think I told them that I will meet with you guys today, and they tell us what's going on, and so I will let them know that this is very exciting. Thank you very much.
Yeah, and we have talked in the past about other projects that you've been a part of, and we've tried to do some grant applications together, and it's I know that you do incredible work, so we're thrilled and excited to help support the project. And I'm sure, Kathy, go ahead. I'm sorry.
No, I was just going to say it's very exciting and congratulations. And we love giving these little holiday gifts right before the holidays. It maybe brightens your holiday a little bit more.
Thank you and congratulations. We really look forward
Thanks
to hearing more about the project throughout the year, and excited to see the outcomes. So thank you for your tremendous work.
Yeah, thank you as well. I think this is really nice.